Thank you so much for inviting me to speak at this event. And I actually graduated alongside with Swang from UBC's Masters of Data Science program in 2018. I had sort of a bit of a non-traditional path to career science. So I got my bachelor's and master's degree in earth and environmental science. And then I sort of pivoted my career more towards the data services. And since then, I have been working in this space with Realtor.com. So today I am going to be talking about the search engine behind Realtor.com and what exactly goes behind it and what's the thinking behind the services that we provide on Realtor.com. Okay. My mouse just disappeared for a second. Okay, so on.
Oh, sorry, I just have to interrupt you that your background is flipped, I think. If you have your video mirrored or not mirrored, I forget what it is. It's not a big deal, but just your Zoom background is flipped.
Is it okay now?
No.
Oh, okay.
Now it's, I think it would be right.
Is it okay now?
I think you have to just press apply.
Wait,
or close it.
Actually, there is no apply button over here. I just see the mirror, my video thing, checkbox.
Try turning the video on and off again.
Okay, let me try that. Is it okay now?
It's still flipped for me. Yeah, this was also a problem at another talk. So
I can quickly, if you want, I can quickly try to flip the image. Would that work? Or we continue with this?
Or also, it's not too much. It's not a big deal because we can edit the video later, just so you know.
Okay, if you just give me a second, I can quickly do that.
Okay, thanks.
Okay, 1 second.
Sorry about that. Yeah.
No worries. Let's see. Just give me 1 second.
Yeah, and just I saw some more people join, so just a reminder to submit your questions via Menti during the presentation, and we'll answer them all at the end. And or also you can upvote other people's questions.
Is it okay now?
Yeah, all good
okay.
now.
I just went ahead and I downloaded the image again. I don't know what went on there.
Okay, yeah.
Okay, just 1 second again. Oh man, I'm just trying to find the slideshow. Thank you. Okay. Okay, are you able to see it now properly?
Yep, all good. Thanks.
Okay, sorry about that. Let's continue.
Yeah.
Okay, so in my talk, basically, what I'm going to do is basically have an overview of what Realtor.com is, because when I joined the company, I did not know that much about it. So let's talk about, what do we exactly do at Realtor.com. Then, we have a lot of services that we provide from our search engine side. So I'm going to be talking specifically about a project that uses data science services and data science model. So basically, what's the motivation behind that project? I'm going to talk about that as well. Then we can get into a bit of the model development, and then how do we deploy the model into production, and what kind of future improvements do we see for this project moving forward. And at the end, I do want to keep some time for question and answers for the project, but in general, like for women in data science related questions as well, if you have any for me. Okay. Okay, so what exactly is Realtor.com? I'm sure many of you must have heard of, online real estate services such as Zillow, Realtor.com, and Redfin. So, but what exactly do we do at Realtor.com? So, at realtor.com, everything starts with the home. Home is so much more than, just four walls and a roof. Like for many families, it means safety, memories, comfort, and much more than that. So it's more or less, sort of an enduring pillar, not just for American people, because that's where we do our business, but for everyone in the entire world. So within some, internal research that we did, we found that, over 90% of people say that home ownership is really important for them. It's a very important aspect of their life. And it often represents one of the single most biggest purchase that, they do throughout their lifetime. And it comes roughly about, more than 60% of their net worth. So definitely being a home owner and, going through this process is a very important aspect of many people's lives. Over in 2021, there were more than 6.12 million homes that were sold. So it is no surprise that residential real estate market is massive. It is approaching almost $2 trillion in annual transaction value. And it is also a part of a much larger ecosystem, which might contain other services such as mortgage, insurance, home improvement, etc. And so actually Amherst Capital Management recently estimated that, American homes are the biggest asset class in the world. Their collective value is almost nearly $25 trillion, which is greater than that of all shares in the US stock market. So needless to say, real estate is a really massive market. Since we are dealing with so many consumers, millions of consumers at a point of time, so that's a fact that, there's a real pain point for our consumers that exist when it actually comes to real estate and home ownership. And if a company exists to, solve a problem, this is a problem that we are trying to solve for everyone, because buying and selling home is a very complicated process and a very high stakes endeavor. I'm sure if you talk to anyone who has gone through this journey of, home buying or selling, they can tell you it's a lot of work that goes into this entire process. So our mission at realtor.com is very simple. We want to empower people by making all things related to home buying very simple, efficient, and enjoyable for them. And a strategy at realtor.com is to build an indispensable resource for homeowners, home seekers, and the professionals who serve all of these people by offering them, the latest information, the best information, and all the tools and guidance that they need throughout their home buying journey. So as a leader in real online estate space, we actually bear a portfolio of many different services because we don't only cater to people who are buying home, we also cater to the real estate professionals such as agents. And we have designed all of our services just to make this entire process for consumers as well as agents to be much more efficient and more suited to their needs. So keeping all of this in mind to a significant degree, like our performance demonstrates the value that we are bearing. And this actually you can see is, you can see this by the acquisition of realtor.com by News Corp in 2014. I'm sure most of you must have heard of News Corp. It's a massive mass media company possessing a variety of different brands such as the Wall Street Journal, Dow Jones, and HarperCollins as well. So these properties that News Corp has its portfolio, we attract hundreds of millions of consumers every month, and realtor.com definitely benefits for the viewership of all these other portals that we have. So as I said, moving on to the motivation behind the project. So search engine is a massive search engine that we have. That's the sort of the core functionality that we have at realtor.com, because people are basically, trying to search for the best home suited for their needs. So we have many services related to search engine that we have, but I'm going to talk about a specific project, which is called the Search Ranking Project. And let's first get into what's the motivation and what's the problem that we are trying to solve over here. Okay, so looking at realtor.com, we have our viewership steadily growing massively every year. You can see in 2018, we had around 61 million. unique users hitting our website every month, and that went on to increase to 72 million in 2019, then 86 million in 2020, and we crossed 100 million plus unique users every month in 2021. And that was definitely like working from home and just being at home was definitely a contributing factor to this, because everything just went digital. So in the past few years, we have had more than 45% increase in our consumer viewership on our website. So because we have so many millions of consumers coming up to realtor.com, search experience, the type of search experience that we're providing to the consumers is really, really important over here. That's one of the core services that we are trying to offer. So I actually just have sort of an example, what it looks like when anybody goes to realtor.com and where sort of the problem starts. So basically, this is the home page of our website. And, if anybody goes in there, you can type in any city, state, any geolocation if you want to search all the properties. And once you come to this, once you put in the city that you want to visit, and yeah, you come to this page. This page is specifically known as the SRP page. I'm going to be using this acronym a bit later on as well. So this is what the search results page is. And that simply just means that a user types in a query, like, show me all the listings in Manhattan, and you can put in different filters such as, minimum 10 bed, not 10, 2 or 3 bedrooms, or, something more than that. And you would get, all the listings matching that user query. So this is known as our search results page. So once you come here, you can see the list view as well as a map view, but you can see, and actually one thing also I want to show over here. So once you get all the listings, what you can also do is sort the listings by different criteria. Our default is known as the relevant. What relevant means, I'll talk about that later on, but you can also sort the listings based on, the price point or, the distance. We have different sort of criteria that you have over there, but relevant is our default criteria. And basically, as the name suggests, is just means, what are the most relevant listings in that area, sort based on that order. And how do we calculate relevancy? I'm going to talk about that later on. But what you can see over here is, I'm scrolling down, you can see there can be hundreds and thousands of listings matching a criteria, and you just saw that there were 206 pages of listings. So this is where the viewer and the consumer fatigue sort of, starts setting in. Just imagine, like, is anybody going to scroll through 206, pages worth of properties? No. Like, what users do is, they would probably look at the first page, or maximum the second page, and then we sort of just lose our attention over there, and we just move on to maybe a different website. So basically, users' attention is very short-lived, and we have seen that only less than 10% of the users actually go beyond the first page, and more than 50% of the clicks on our web pages are within the first 5 listings. So here, I also actually have some graphs just to demonstrate the idea over here. So on the left one, you can see like on the x-axis, we have the click probability, and I'm sorry, on the y-axis, we have the click probability, and on x, we have the SRP page rank, which is basically, the ranking of the listing on that page. So you can see for the ranks, which are very low, maybe 1 or 2, you have very high click probability, which decreases quite drastically after the first few page ranks. So you can definitely see that the users sort of, lose their interest after the first few pages. And on the right to side, we have graphs which are showing the visit percentage versus the page number as well on the x-axis. And when it says LDP, LDP basically just means listing description page. And what that means is that's a page dedicated to a specific listing. So SRP, as I mentioned before, is a page showing all the listings. And if you click on one of them, then you go to the actual LDP page, which is the listing description page. So like, again, on this graph that you can see, like, we have most of our visit percentage around, 75% on page 1. And then again, it reduces quite drastically while you start going to, subsequent pages. So our goal over here in our search experience is that we want to capture our users' attention and we want to keep them as engaged as possible. So how do we do that? How do we do that? And so basically the goal of this service that we want to provide is that we want to enable users to find relevant listings according to their preference in a very efficient manner. Like we cannot be showing the relevant listings on page 5 or 6, like that's not going to work for us. So just in like page 1 or 2 or 3, we want to show relevant listings to the users, and those relevancy can come in terms of what's the type of query that the user has put in, or what's the sort of historical data of the user, like what kind of properties are they interested in. So using that information as well, we can present them some relevant listings and keep them engaged and provide a better experience, because at the end of the day what we want is we want users to click on our LDPs and submit our leads, because that's how our business is going to make money. So before this service, we used to have a lot of feedback from our users, and I've put one over here. Like they kept on complaining about this, that I'm trying to search for houses, but it keeps showing so many lands and mobile homes. Your search results are basically not relevant and not keeping us engaged. So then they sort of go to our competitors' website. So this is something that we want to avoid, and we want to capture our users' attention as quickly as possible in an efficient manner on our website. So once we decided, okay, this is the problem we are trying to sort of solve over here, we went about, how do we think about the architecture? What kind of model do we want to develop in order to solve this problem? So before getting a bit into this, I want to mention that, behind our search engine, we keep all of our listing data in Elasticsearch service. And because we have I think close to 150 million listings. And so we have a lot of data, and we want to use a search engine service that is very efficient in extracting the data. So that's why we have everything living in Elasticsearch. So whatever we are trying to develop in terms of model, we have to think in terms of, how that's going to apply to the Elasticsearch service. So initially, a couple of years ago, when we started thinking about this issue, how do we solve this? We were thinking about, different data science models, or, how basically what can we do in Elasticsearch in order to extract the relevant listings based on the user query. So at that point of time, we explored the learning to rank plugin that exists in Elasticsearch, but there were a couple of issues I'm going to discuss in a second, but that basically did not really make sense for us. And we decided to make a custom built solution for our service. So why did learning to rank did not work for us was the first thing was that it did not support XGBoost model, because that was a model that we intended to use in our ranking of the listings. So learning to rank did not support that one. And even when we tried other models in learning to rank process, the performance was not that good. And as I said, like in our Elasticsearch, in our entire search experience, performance is a very, very big factor, because we want to get results back really quickly. And like if we don't get results back quickly enough, then the experience is going to be really bad for our consumers. So that is like the number one factor we have to consider for any service that we want to implement behind the search engine. So the learning to rank one did not give us good performance. And also the other thing was, since this was a third-party plugin, learning to rank, we did not want to depend completely on it, because later on it would give us problems if we if we want to make other custom built changes to that one. So here we decided, okay, learning to rank is not going to work for us, and we decided to build a custom solution for us for like our search service. Okay, so we ended up getting into a space where we do our ranking in 2 stages. I'm going to explain that to you, how that works. So basically, we have divided this into 2 domains. The first phase is called the sort, and the second one, as you can see, is called the ranking module. And basically the sort, which is the phase 1, this takes place in the Elasticsearch, and you can think of this service as, a first pass, a very easy sorting that we are doing on all of the listings. And after that, we take the output of, the sort model, and we feed that into the ranking model, which basically uses XGBoost, and, which is a just much more complicated model. And we use many more features in order to, further refine our ranking that we have done. So as an example, if I go in and type the query as I did before, show me all the listings in Manhattan, which has maybe minimum 2 bedrooms. So and just as an example, we have, 5,000 listings matching that criteria. So what happens is we go to the Elasticsearch, we take all of those 5,000 listings, and we have a very simple model that we implement in Elasticsearch. It's a linear regression model, and it is based on very simple features such as, how many photos does a listing have, or how many days has the listing been on market already. So we take all of those features and we apply a linear regression model, and we come up with a very preliminary ranking of those 5,000 listings, as I said before. And then what we do is we now take a smaller chunk, for example, just 100 listings each time from those 5,000, and we feed that into our XGBoost model, which is a part of the ranking library. And in XGBoost model, we have many more complicated features based on, the geolocation and, median prices. And so basically it's much more sophisticated, much more good performance. We feed those outputs into the ranking model, and then we get our final ranking of the listings, which we then display on our SRP pages. So it's a two-phased approach that we have been following for, I think, past couple of 2-3 years, and it has been going quite well for us right now. Like, we have seen very significant changes and changes in our sort of lead submission metrics as well. I wanted to sort of go a bit more into the ranking models as to, which models are we using over here. Like, from a bigger picture point of view, the data science team is the one that develops these models, the linear regression model, as well as the XGBoost model. And once they have developed the model and they have trained the model, then they pass that on to the engineering team, which is my team. And then it is our job to basically productionalize the model. And when I say productionalize, what that means is I take the model from the native, Python language, and I translate all of that into our Node.js JavaScript language, because that's how our search engine API has been sort of, written down. So that's sort of the work that I do in this project. So once I get everything from the data science team, I basically translate all of the model into JavaScript over there. So if we just look at purely at the data science side, while we are training the model, the sort model, which I mentioned before, is the one that is just implemented in the Elasticsearch service. It's a very simple model that we have over here. And what we have used over there is known as the MARS model, which is the multivariate adaptive regression splines model. I always find it hard to remember this name, but basically this model is inherently non-linear in nature. Because we cannot assume, we have sort of the linear relationship between our, target variable and the response variable. So we have chosen this one. This works well with our case. And basically, for Mars model, you can think of it as a piecewise linear model. What that means is that, similar to your least square regression, the relationship of, one or more predictor variables is varying throughout your value range. So it's not like, if you have X increasing, you would have proportionate increase in Y. Like, the change in Y could vary in time, and you could actually have a bigger range over there. Basically, in simple words, how this works is the function tries to find a knot within your distribution. And what it tries is, for example, if you look at maybe, which one is this? Figure A. If you look here, so basically the kink that you see over there, so basically that's known as a hinge function. And what it does is that it would fit one linear model to the left of that hinge and one linear model to the right of that hinge. This is how it will start. After this, it will try to find another hinge. Basically, it will try to break down this function further into different knots so that you have different pieces of linear regression models that can sort of mimic the data more accurately. So if you follow like A, B, C, and D, you can see that it started from 1 knot coming down to I think 4 to 5, but this piecewise linear model, the step function just mimics the data much more better over here. So this is the type of function that we try to generate in our Mars model, and the metric that we use in order to pick up the best model is our MSE over here. And as I said, in the Mars model, we try to keep it really simple. We try to use very simple features over here, such as number of photos, number of bedrooms, number of bathrooms as well. And one thing I also want to mention over here is one of the drawbacks in Elasticsearch is that if I am looking at one listing at a time, all the listing attributes, I won't have access to the listing attributes of another listing at that point of time. So basically, I only have access to things like the days on market, the number of photos, but I won't have information such as what's the relative price of this listing compared to other listings in this area. So I won't have all those relative features. I cannot compare the listings in Elasticsearch. I would just have access to all the attributes of one listing at a time. So this is like one more reason why we want to keep it really simple in Elasticsearch. So once we apply this model, we have a scoring system over here. So basically, all the listings that match the user criteria are then sorted based on a very simple score that is generated using this Mars model. So once we have everything from the Mars model, we feed that as an input to our ranking library that we have developed over here. And basically what that uses is the XGBoost model behind the scene. XGBoost, as many of you may already be aware of, is a gradient boosted decision tree. And basically the response variable that we are trying to develop over here is the dwell time. By dwell time, what that means is how many seconds or milliseconds is a user spending on an actual listing, because that's the thing that we want to maximize. We want people to come and look at the listings and spend as much time as possible on that listing. And if you have someone spending a lot of time on the listing, that obviously is a proxy for their user attention, their interest in submitting the lead on our website. So this is the response variable that we sort of want to predict using the XGBoost model. So in this model, compared to the Elasticsearch one, as I said, we have much more complicated features that we want to use in our model. Like on the right side, basically, this was just one of the feature importance diagram from one of the versions that we did a couple of months ago over here. And my aim over here was to show you the kind of features that we use in the model. We still have the simple ones, such as the age and days on market, but we also have features which are using other features to come up with medians, or what's the relative price, or what's the distance from other listings. Such things are also considered in this model, and it definitely gives us a much better performance than just using the sort model itself. But over here, again, one thing I want to mention is like although the modeling is not that difficult, but we have to deal with a couple of things beforehand. One of the things is of unbalanced data set. So how that comes up is like, the search results page, as I showed to you before. Just imagine on page 1, you have around 50 listings, right? But at the end of the day, users would only maybe click on 1, 2, 3, or 4, or 5. The number of clicks that we have on our web page is much less than the number of impressions that we have on our web page. And by impressions, what that means is like that listing appeared on your web page, but nobody clicked on it. Okay, so impressions is that, it appeared, but if actually someone clicked on it, then that counts as a click or a view. So all the listings have a lot number of impressions, but not that many views. So basically that leads to an unbalanced data set for us. And we do deal with that. We basically undersample our data set using some different techniques behind the hood, but we try to make it a balanced data set, because unbalanced data set as everyone in data science, that's not good for our modeling purposes. Apart from that, there are many other things that we do is that, just to normalize our response variable, we do some Gauss rank conversions as well. And I think those are sort of the main two: data engineering and, just the model, the data wrangling side of it, like basically just preparing the input data as of the best quality for our model. That's what we do over there. And the metrics that the data science team uses in order to pick the best model is NDCG. And I think the MAP and MAR as well. I think that's what they use as well. So basically, the data science team is using these two models. They train both of these models for us, for the engineering team. Like, this was a bit about the actual models that they were using, but just as a high level overview of data flow, what happens is like all of our data at realtor.com lives on AWS, on the cloud service. And most of the data, the historical data, lives in S3 buckets, and basically the data lake, that's where the data science extracts all their data from. So in the historical data, we might be using data such as, what are the search results that people have looked for, what's the dwell time in the past that, people have recorded on different pages, because we are tracking all of this information, how much time is every user spending on each different page or on each different listing. So we do have all of this historical data living in data lake for us. And the data science team basically uses AWS, Athena, and Glue to extract this data for them to train the model. All of the feature engineering that the data science team does, and also calculating the location and search related features, they basically do that in Jupyter notebooks in EC2 instances. And I think in the past 7 or 8 models, I would say they come up with a list of, around 200 listing features per model. That's what they start with. But at the end of the day, for our final models that have gone into deployment, there are probably around maybe 30 to 35 features that we sort of, come down to, starting from 200. So this was the model training. Of course, then we have to go through the process of model validation as well. As a data scientist, I'm pretty sure you know that, all these models that I've talked about, they depend on different parameters, such as, the number of trees, the tree's depths, and, how complex do you want the model to be? What's the performance that you're looking for? And, splitting all of your data into the training, validation, and test set. That is actually really important for us to do over here. And definitely for all of the models, we perform the grid search to find the best hyperparameters for the best performing model. So this process is quite iterative. Like, the data science team goes through, I think, at least 3 or 4 cycles just to, come up with the best features and come up with the best model that they find the best model is. And basically, at the end of it, what they do is they convert the model file into, a pickle file or something for the engineering team to actually deploy into production later on. So in terms of model evolution, what I want to say over here is this project, I think it started probably 3.5 years ago. And this is definitely not something that, we worked on once and then, it's in production forever. This is something that is a very iterative process. I think in the past 3-4 years, the frequency that I've seen is like every 3 to 4 months. So basically every quarter, we would have a new version of model that we would have to deploy into production, because, the data changes, training data changes, and the product requirement changes as well. As an example, like, sometimes the product would think that, okay, if you have listings such as, just the lands or mobile homes, you would, because their prices are so low, they usually, sort of wiggle their way up into, the top ranks of the page, just because price is a very big predictor of, the relevancy that you want to come up with. And just because they have such low prices, they are often at the top of the search results page. And that is not the ideal situation, because people don't want to look at land and mobile homes until unless they specifically say so. we have seen that most of the people are mostly interested in, single family homes or condos, but definitely not land or mobile. So sometimes product would think, okay, we want to demote such kind of listings. So, based on different type of product requirements, we might have, different things that we want to demote or promote within our model. So we have such kind of iterations going on every quarter, and we have to just, keep up with the new methods. And in this model evaluation, basically, it's sort of a summarized timeline of the projects that we have gone through in the past couple of years. But basically, in 2018, we started with very simple model, limited features to sort with. And I think at that point of time, they were not using any regression model, or definitely not XGBoost. So it was a very simple sort based on, maybe number of photos or on the days of market. Then after that, we progressed into the machine learning model phase of our development. That's where we started applying the linear model and the XGBoost model, the two model approach that I showed to you. And we have since followed that because it has been going very well for us. But every couple of months, we have made some changes because, next stage, we had like improved features for training. Earlier, we were just using very simple features, but now we wanted to add features related to the location of the listing, or, what's the relative price of this listing compared to other listings, and, what are the school ratings in that area. So basically, we wanted to improve the features for training. So that would mean that, we have a new version for deployment. After that, we had many phases where we wanted to improve the entire training data set that we were using for this model deployment. Like, for example, earlier we were just using the user search history, but then we also wanted to use the data related to the lead submission of, okay, people have submitted leads on this in the city, or any example. Basically, we had data related to that as well, so we wanted to combine that into our training data set as well. After that, with the new features, the new data set, we also wanted to add additional data sets related to our iOS and Android apps as well, because we sort of treat them as different viewership. So we want to add that into our training data set as well. Although I would say these were not minor, but still relatively good improvements. But I think the biggest sort of development or the improvement that we wanted to bring about is the personalized search experience that we want to sort of present to our consumers. Like these days, everybody uses, Netflix, Amazon, YouTube, and, personalized recommendation is no more, it's sort of an expectation that the users have. Like it's no more, this extra fluff that you're providing. It's an expectation that, okay, I will be served personalized search experience. So till now, actually, that's the one that I am working on these days. But till now, we have been like anybody who types in one query, like me versus somebody else, we would be presented with the same results. But what we want to do is we want to use the data, my historical data on our website. Like, what kind of listings have I looked at? Are there specific type of architecture that I'm really interested in? So we really want to include this type of data in our search relevancy, just to present them, relevant search listings. And another data set that I can actually think of is popularity metrics. We want to also include data such as, how many clicks has a property received, or, how many views has the property received, because these are sort of, very good proxies of, the interest of the user in a specific property. So we do want to include those metrics in our data set as well. But whenever we think of any new data set, we also obviously have to think about, if it's a live feature, it's a runtime feature, or is it, something that's just going to be updated every 7 days or something like that. So we have to think about a lot of, where is the data coming from? Do we have to index that in our Elasticsearch or not? So considering that, there are many more improvements that we actually have to make, but we do have a direction that we want to move into. So this was like more about the data science side of it. So, data science did their work, trained the model, developed the model, they pickled the file and everything. And then they sort of gave that to the engineering team. So it comes to me. So now what happens after that? So the first and foremost thing over here is the data science team actually develops the model using offline data from our data lake, right? But when I have to translate that model into my Node.js framework, I am actually using live data from the Elasticsearch. And basically why that is important is, how do I make sure that the translation that I'm doing from Python to Node.js is correct? Because that is really important. And there are always, there's scope of error, while I'm translating the model. And when I say translate the model, it includes everything. Like I have to basically use the pickle file that the data science team provides to me. But the thing that takes the most amount of time out of my workday is the feature mapping. And basically what that means is, all the features that the data science team developed that we just talked about before, I have to somehow convert that into our Node.js in a way that it's able to use the live data from our Elasticsearch clusters. So in all this translation, it's a very time-consuming process, which we want to sort of improve later on. But the thing is, how do we make sure that the model that I got from data science team has been properly translated on the engineering side? We started doing that manually, but it was a painstaking process. And this is how we came up with this model evaluation framework. It's an automated framework. And basically what that does is it goes to the data science repository on one side, pulls in all the Python code, all the configuration, all the training files and everything. And it does the similar thing on our Node.js side as well. Like it takes all of the translated model on the other side. And what we have done is we have a common test data set that we have developed. And basically this framework would use that data set as an input into the model, one on the Python side, which was the native one, and one on the Node.js side, which is a translated one. And at the end of it, we want to compare the outputs, which are the final ranking scores, if they are matching or not. So the final scores, as well as all the feature value scores, we want to compare that all of those are equal and we are getting all the expected results that we want over here. In theory, it sounds, yes, it's easy, but every time I have worked on a model at this stage in the framework, I have always found some error or the other that, you have not translated the features correctly. So I would say that this is inarguably the most important part of the entire project, the framework that we have developed over here. And like this is automated. By the time I was working on this project, it was already there. So I'm like always like every day thanking the person who actually built this framework for us to work on. So once the model evaluation framework is done, so basically all the model work is done from our side, from the engineering side. And basically the next stage that we have is the A/B test that we want to conduct. And since, I was saying that this is a very iterative process, so at each point in time, we would probably have 2 to 3 models in production. And, if a new model comes up, then we slowly want to start A/B testing this new version that we have over here. So like at Realtor.com, all of our A/B tests are set up in Optimizely, which is used specifically for A/B testing. And one thing what we have done is usually when you do A/B test, you would have to make a lot of front end changes because, what's the control that you want to send or what's the variation that you want to send for that project is usually controlled by the front end people. But we have configured that in a different way. We have put in all of our configurations on our backend side in our config file on GitHub. So basically the front end just has to say that, we are selecting the relevant type of sorting, the sorting that I showed to you quite in the beginning. So they just have to say that. They don't have to specify any control or variation. That basically is done by everyone in the backend engineering side over here. So what we do is, once we deploy the model into production, we don't immediately start sending traffic to it. There's a reason behind that, because we have a big effort at Realtor.com going into, improving our search engine optimization. And basically what we do is, once the links for, the A/B test are ready, the SEO team basically tests the link and just they want to see that, it's crawlable and basically Google does not have any problem finding those links. Otherwise that will be really bad for our search engine optimization effort. So once the SEO team basically signs off, everything is good, then we slowly start ramping up, traffic to our websites. So we'll start, maybe with 2%, 5%. And, after some time when, we are looking at our metrics and we see, the model is doing a good job, then we ramp up the traffic to, maybe 50, 60 or 100%. And definitely there have been times in the past I've worked on some models and we have not seen good results. And then we just decided that, okay, we are not going to go ahead with this model. We are not going to put that into production for 100%. And we just took it offline. So A/B test has been like really useful for us to, sort of validate, what's the model going to look like. And, are people basically liking this new model or not? So like in A/B testing, but how do we measure that, if this model is a success or not? How do we do that? So one of the most important decision-making metric for us is the SRP to LDP conversion rate. Again, SRP was the search results page where you have all of the listings, and LDP is one specific listing. So we want to see what percentage of users are actually going to specific LDPs from the SRP pages, because if we are showing relevant listings to them, then definitely we would expect that the conversion rate increases by quite a lot because we are keeping them engaged. But if we see that there's a drop in our conversion rate, then definitely that means that, we are not sharing sort of relevant listings to them, and basically they lose their interest and move away from our website. So that is the most important decision-making metric, but we do have other supporting metrics that we also look at. And some of them include, what's the average click-through rate, or, what's the average lead submission rate, and what's the average dwell time. None of these metrics are like, if, for example, the average lead submission rate is decreasing, it does not mean that, it's just because of our model. There could be some other factors as well. So we always have to keep that in mind. Like these are not just, direct correlation of these metrics over here. So we have to keep all of those things in mind. And I think the A/B test team basically has certain thresholds set up, if the significance level has been achieved or not. And basically based on that, we decide, if a model is a success or not. And if it's not, we sort of have to scrap it at that point of time. So like, what I wanted to do over here is, like, I've talked about the model and how we deploy that into production. I want to take a step back and just show the architecture behind the search engine, like how exactly is all of this working in production. So like over here, you can see, for example, a user submits a query, and that basically goes through our GraphQL service. GraphQL service is just a service that can, get a response from multiple APIs at one point of time. So from the GraphQL, the user query goes into our search API. This is the main search engine over here. Using that query, what happens first is the query then goes to the Elasticsearch. Within Elasticsearch, we have the phase 1 of ranking, the sort model, the Mars model that we talked about. Once that is applied, we get the results back into our search API over here. Then the second phase of ranking starts. The results actually go into a ranking module over here, and you can see sort of a bigger detailed picture of the library. And within the library, we have the XGBoost model over here that basically re-ranks, whatever the Elasticsearch gave to us. It does all of the re-ranking, and then it returns everything back to the search API. And then it goes back through the GraphQL to our actual, like the device, maybe it's a mobile or web page, but that's sort of the overall architecture that we have been following. Of course, performance is really important in the Elasticsearch. This is where we have millions of listings living. So the performance is definitely the most important factor that we have to consider, while we are developing the models. So In terms of, like, I've already described the process, but just again for a high level overview, in the life cycle of the project, every time we have a new product requirement, or we want to update the training data set, or we want to, train with new features, the data science team basically, creates the model. They do the model evaluation, the feature mapping and everything. And once the model is ready, it goes to the data engineering team, where we translate the model into Node.js. From there, we deploy the model into production. Once it is deployed, it basically goes through experiment setup for A/B testing in Optimizely. Then we run the A/B test for some specific amount of time, and based on if the model is a success or not, we might have new requirements, or we might not. If it's performing really well, we just leave it into production. But maybe the next quarter or something, we would again go through the entire process of having a new model, and just going with the data science team, data engineering team, then the A/B test, and basically the circle goes on. This is the life cycle of this project. And lastly, I wanted to touch a bit upon, how can we improve on this project. There are many, many improvements over the years that we have thought of, and because we have seen the sort of project take shape, and working on it for so many different iterations, we do have a bunch of pain points that we really want to sort of improve on in the next upcoming quarter. I can touch a few on a few points over here. So first of all, is definitely using some advanced algorithms. As I said, due to our limitations in learning to rank and in Elasticsearch, we are using very pretty like a basic Mars model over here. We definitely do want to upgrade that in Elasticsearch, because I think for Elasticsearch as well, we have been using a pretty old version, and we want to just upgrade the Elasticsearch in itself. And I think with the new Elasticsearch service, they do have some new models that we can implement in terms of ranking. So we really do want to look at that. In terms of XGBoost as well, so like we have faced this issue many times, that the Python version of XGBoost keeps on improving, but the Node.js version of XGBoost does not improve that frequently. Just as an example, this might not be like the true numbers, but for example, every year we have a new version of XGBoost in Python, but in Node.js we would have something in once in 3 years or 4 years. So there's always sort of a lag between these two XGBoost versions. So even if the data science team has some new things that they want to use in XGBoost, or new methods that they want to develop, ultimately we are not able to take that into production, because we are not able to make those same changes on the engineering side of it. So that lag is always there, and we do want to fix that. Other than that, as I mentioned before, like including personalization and popularity metrics is a big, big initiative that we are working on these days. So recently, I think probably a year ago, we created, by we, I mean Realtor.com, not my team, we created a specific API, the consumer service API, whose sole aim was to collect all of the data about the consumers, their historical activity, and come up with different metrics, come up with their preferences. We really, really want to leverage that data into a ranking project, just to make our recommendations much, much more relevant. Like personalization is definitely something that is just expected these days, and if you don't provide it, people are definitely going to drift away from your website. So we definitely want to put that in there. The last one, when I say improve architecture, actually that is more on the tech debt side, I would say. The translation of the model just takes so much time, from Python to Node.js, that we are not able to keep up with the models as fast as we would like to deploy them. Like sometimes product, wants to deploy a model every 2-3 weeks, but we are not able to do that because it just takes so much time to translate the data science model to the engineering perspective. So we have actually been working on that this quarter, and one of these proposed solutions that we are trying to come up with, that we get rid of this entire model translation altogether, and we want data science team to sort of maintain a sort of a fast API from their side, so that within the search engine, if you want to use a re-rank model, instead of writing everything in Node.js, we can just make a call to the data science team API and get the results directly. So this would eliminate all of our need of translating the model, but also that of model evaluation framework, which is another pain point for us. So if we are able to eliminate these two factors from our entire deployment process, then that would just make everything much more easier and faster and easier to maintain as well from our side. So that is also something that we're working on this quarter, and hopefully we would have a solution like in a couple of months, but this is a very high visibility project. So definitely people are spending a lot more time thinking about, do we still want to keep a two model approach? Can we somehow combine that into one model? Or, can we just have a one data science team API that we can directly make a call to and, not do all of this translation? So if you're able to achieve that, I think we would be in a much better position to, deploy the models much faster than we do right now. Yeah, and it would basically just make everybody's life much easier, I think, as well. So this was sort of the work and an overview of the search engine that we have at realtor.com. And I am open to any questions if you have related to this project, or also in general, women in data science related as well.
Okay, thank you so much. I'll just like jump right into the Q&As because I see there's like a ton of questions and I don't think we're going to get through all of them, but I'm just going to start with the highest upvoted one and kind of relevant to the what you were talking about in the last slide. So this person asks, is the model trained every day? And can you tell us about an example where you had to fall back to the previous model?
Yes. So no, the model is not trained every day. Right now, I would say that's more on the terms of maybe 3 to 4 months. It is definitely not the ideal situation because obviously our data is changing every day. But just with all the technical debt that I talked about, going through from one phase of the model to the actual deployment, it just takes so much time that we are not able to train the model every day. So it's more of, I would say, a couple of months. That's the frequency that we are training at these days, but we definitely want to come down to maybe every day would be the best situation, but maybe a couple of weeks. That's what we are trying to aim at this moment. And what was the second part of the question?
And have you ever had to like fall back to the previous model, like I guess if the A/B test, but you kind of mentioned the A/B testing. Yep. Good.
Yes. So this model was probably, I think, 6-7 months ago. And actually that was the one that I was talking about, when I said, sometimes you want to demote mobile and, the pending listings or stuff like that. So we did develop the model. It went through the A/B test, but the results were not good. We actually had a decrease in our, the conversion rate in our viewership over there. So we did take that model offline. And then it was sent to the data science team. Like we wanted to do some kind of analysis, like, why are the rankings correct? Why is it not performing correctly? But it sort of got lost in translation, to be honest. But yes, there was a time that we had to take the model off from production. But as I said, at any point of time, we have like 3 to 4 models running like concurrently. So it's not like, we wouldn't have any ranking model in production. It's just that, the latest version will not be available.
Okay, thanks. Moving to the next question. Can you give a few comments on the similarity and difference between the ranking and recommendation problem?
So as I said, like from my perspective, what we have right now within our ranking services, we are not using any user data. We are just purely using the listing data at this point of time. But we do have a recommendation services as well, not related to this project, but we do have recommendation services as well. And the core data that goes behind that service is the user data, the user preference data that we have collected over the time. So that's sort of the main difference. We are trying to incorporate the user data in our ranking system, but right now we haven't.
Right. The next person asks, why would you choose Athena query instead of another query database?
I wish the decision rests on me, but that's not the case. Like that's like all of our data at realtor.com, not just based for this project, but all of our data is on AWS, and basically the omniture data, which is basically the clickstream data that our website is collecting, as well as all the user search related data, as well as the historical data. It first goes to the data engineering team, which performs some data transformation. And then basically that goes back into the data lake, and all of our data science team uses basically data from the data lake for all of the training. It is not up to me. That's how this is where the company decided, that's where they want all of their data to live.
Right. Okay, thanks. I'm just gonna open the breakout room so our team can talk to the next speaker, but everyone in the main room, don't join a breakout room. We're still doing the Q&A. Sorry. So the next question is, what is the query time and how did you optimize the architecture to improve the query efficiency?
So for our search results query, I would say we sort of have, the maximum is 200 milliseconds, but average time for our sort of query response is, I would say, 60 to 70 milliseconds. But this is, as I said, like in the search query, the search re-ranking is just a small part of it. Like we have different sort of things happening while we are making the search query. As an example, when user types in an address, sometimes it would go to the actual parser API, which basically parses, what the user has typed in and converts that into a valid US address. That's just an example, but we have many services working at the same time while the user is making a search query. The ranking is just a very small part of it. So what we try, and that's like, I would say average of 60 milliseconds, but definitely we have times where the max is 200, but beyond that, we don't consider anything like that would be just too slow for us. And while optimize, sorry, you were saying something?
Well, it's like, okay, right, sorry, I shouldn't.
So like average is 60. For optimizing, definitely, like we look at the type of model that we're using in Elasticsearch as well. Like one example I could give is, just of optimizing is sometimes there might be a request from the data science team to implement a new feature, like some data source that we might not have in our Elasticsearch at that point of time. So it's our job to get that data into Elasticsearch, and that could mean that we have to sort of manually insert a new data dictionary, or do we have to make another API call to get that data in runtime? So there could be different sources over there, and we have to make sure that the new data that is coming in order to calculate a certain new feature that the data science team has requested, it has to be under a certain threshold. Sometimes we have had this sort of situation where it's just taking too much time, and then we have resorted back to a solution where we want to calculate this feature offline, store that in some database, which might be getting updated daily in the backend. But from our side, we don't have to do any computation. We just grab that from the, we just grab that from from a data source which has been pre-computed as compared to us computing the entire feature within the Elasticsearch itself. So this is how we try to optimize that we have a very performant system for us.
Okay. And then last question, and then I'll let you go. So this person asks, oops, I guess we kind of answered that one. What are the what metrics does the service keep track of on the dashboard?
So yep, I think I went over that, but mostly the metrics, as I said, ideally we want to sort of, measure our user engagement and how relevant are the listings that we're presenting to them. The metrics that sort of, act as good proxy to them is, how many people are actually clicking on the listings that we're presenting to them on the search results page. If we see a lot of people doing that, then it means the search results are quite relevant. But if we see a lot of people, going to the actual search results page, but not clicking on anything, that means our search results are not that relevant. So that's one of the metrics. Other metrics is like how many people are submitting leads on our listings. Obviously, if they're interested, we would have an increase in the number of leads and the percentage of leads that are being submitted. But if we again have a drop on that one, we sort of, that means like our listings are not that relevant to our users within this model. So these are the sort of type of metrics that we try to keep a close eye on our A/B test dashboard, and that's how we sort of decide, if this model is worth, staying on, or did we have a previous model which was performing better, and we do want to just keep that into production.
Okay. Well, thank you so much again for your presentation and answering our community questions. Like, I know I learned a lot, and I think, yeah, everyone did hear too from, the comments in the chat. And then, because we know it's like, it takes a lot of time you had to take some time out of your day, and then you had to make the presentation probably in your own time too. So thanks again for that. And then just, even though we didn't really talk about it, why Women in Data Science, like Stanford too, started is because like we just want to see like more women at conferences in data science. And so, and often maybe women don't maybe submit to speak at the presentation, and we know it ourselves, like organize even the people who get the speakers, like it's hard to find people to speak at this conference. So thanks again for like coming out and like representing for women in data science.
Thank you so much for the opportunity. And like, if anybody wants to connect with me and have any questions they want to ask later on, feel free to do that on LinkedIn. And it was good for me as well, because I've been working on this project for very long, so it just gave me sort of an opportunity to just summarize everything. There's just so much information just floating around everywhere, so it was a good opportunity for me as well, and I really enjoyed it. So thank you so much for the opportunity.
Okay, thanks again, and please stick around.
Sure.
And for everyone else, we're going to maybe take like a 1 or 2 minute break, because we're gonna, and while we get our next speaker ready to go. So see you. I'm not going to open the breakout. We're not going to do the networking. So see everyone in a few minutes. So go grab a drink of water, use the bathroom. Thanks.
Okay.
Oops, sorry.